Dear students, our next topic is the types of optical fibers. Optical fibers are classified based on the material, the number of modes, and the refractive index profile. First of all, there are three essential types of optical fibers commonly used today. All three varieties are constructed of either glass, plastic, or a combination of glass and plastic. That is the material theory behind the material of optical fibers. That is either glass, plastic, or a combination of glass and plastic. So we have to go through the theory part. First of all, the core is made of plastic and the cladding is made of plastic, or a glass core with the plastic cladding, and it is called a PCS fiber, that is plastic clad silica. Third is glass core and glass cladding. Now it is called a silica clad silica, SCS fiber. You just note down it. And the optical fibers are made up of materials like silica and plastic. Silica means glass. The basic optical fiber material must have the following properties. That is efficient guide for the light wave. That is, it is effectively guide the light through it. It is low scattering losses. The scattering losses you will study about later. Scattering means the light is scattered throughout the media. The absorption means some amount of light is absorbed by the fiber. Attenuation is also termed as the loss of the fiber. And dispersion also, it is the light is dispersed throughout the media. The absorption, attenuation and dispersion of optical energy must be low. Based on the material used for fabrication, they are classified in two types: glass fibers and plastic fibers. Glass fibers means the fibers made of glass, and plastic fibers means the fibers made of plastics. So the glass fibers. The glass fibers are generally fabricated by fusing mixtures of metal oxide and silica glasses. That is, by fusing the metal oxide and silica glasses, the silica has a refractive index of 1.48 at 850 nanometer. This 850 nanometer means it is the wavelength. At 850 nanometer of wavelength, silica has a refractive index of 1.458. Then to produce two similar materials having slightly different indices of refraction for the core and cladding, either fluorine or various oxides such as B2O3, GeO2 and P2O3 are added to silica. That is, in order to make the more refractive index, to change the refractive index profile, we just mix the fluorine or various oxides. Then examples: the silicon dioxide core and P2O3 and SiO2 cladding. That is, core is made of silicon dioxide and cladding is made of P2O3 and SiO2. Again, the core is made of germanium oxide silicon dioxide and cladding is made of silicon dioxide. Again, the core is made of P2O5 SiO2 and cladding is made of SiO2. That is the examples of glass fibers. Again, the plastic fibers, I already told you, some cases the core and cladding is made of plastic. Some cases the glass core with the plastic cladding. The plastic fibers are typically made of plastics and are of low cost. We already know that. If we have a glass made of glass and plastic, so the glass made of plastic is very cheap and is very durable. The second point is, although they exhibit considerably greater signal attenuation than glass fibers, the plastic fibers can be handled without special care due to its toughness and durability. One of the main disadvantages of the plastic fiber is it has greater signal attenuation. That means more signal loss is occurred in the plastic fiber. That is, but plastic fibers can be handled without special care and toughness and durability. Due to its high refractive index difference between the core and cladding material, plastic fibers yield high numerical aperture and large angle of acceptance. I already told you, the numerical aperture means the light gathering capacity of an optical fiber, and its equation is numerical aperture equal to root of n1 square minus n2 square. n1 is the refractive index of core and n2 is the refractive index of cladding. And plastic fibers have large angle of acceptance. That is, high angle of is accepted to the fiber. Some of the example, you just note it. A polymethyl methacrylate core N1 equal to 1.59 and a cladding made of its copolymer. It's a plastic type that is and a polystyrene core and a methyl methacrylate cladding. Just write down the example in the examination. It is two types of plastic fibers made of core. The core is made of polymethyl methacrylate and cladding is made of its copolymer. Then the optical fiber is based on modes or mode types. That is, the mode means the number of light is passed through it. That is, mode is the one which describes the nature of propagation of electromagnetic waves in a waveguide. That is single mode and multi-mode. Depending on the refractive index profile of fiber and the modes of the fiber, there are mainly three configurations, that are single mode step index, multi-mode step index and multi-mode grade index. I will tell you later. That is, based on the number of modes that propagate through the optical fiber, they are classified as single mode and multi-mode. The single mode means only a single mode of light, that is, simply means a single light is passed through a fiber, that is called a single mode fiber. Multi-mode means a multiple light is passed through a fiber, it is called a multi-mode fibers. Single mode fibers. In a fiber, if only one mode is transmitted through it, then it is said to be a single mode. I already told you this is only a single light. A typical single mode fiber may have a core radius of 3 micrometer. You just note about the diameter of the core in case of a single mode. It is 3 micrometer and a numerical aperture of 0.1 at a wavelength of 0.8 micrometer. The condition for the single mode operation is given by the V number of the fiber, which is defined as V less than or equal to 2.405. That is, V is an important name in the optical fiber communication. You just note down the V number. The V number for the single mode fiber is less than 2.405. Here N1 equal to refractive index of the core, A radius of the core, lambda wavelength of the light propagating through the fiber, delta relative in refractive indices differences. And some of the peculiarities of a single mode fiber, that is only one path is available. That means only one mode of light is passed through a single mode fiber. The V number is less than 2.405. I already told you the V number. That is, the V number is less than 2.405. Then core diameter is small, no dispersion, higher bandwidth, that is 1000 megahertz, used for long haul communication. Fabrication is difficult and costly. Then the figure of a single mode fiber and a multi-mode fiber. The inner portion is called core and outer portion is called cladding. The single mode fiber only single mode of light pass through a single mode fiber. In the multi-mode fiber, there is a multiple mode of light. You just note down the figure, that is single mode, single light is passed, and multi-mode, multiple light is passed through it. Multi-mode. Multi-mode fiber, if more than one mode is transmitted through optical fiber, then it is said to be a multi-mode fiber. The larger core radii of multi-mode fiber make it easier to launch optical power into a fiber and facilitate the end-to-end connection of similar powers. That is, the core radius of multi-mode fiber is greater. That is, in order to make more light is passed through multi-mode fiber, the core radius is greater and make it easier to launch optical power into the fiber. Then some of the basic properties of multi-mode optical fibers are listed below. That is, more than one path is available. That is, in this figure you can already see that there is more than one path is available in the multi-mode fiber. Then V number is greater than 2.405. That means in case of a single mode fiber, the V number is less than 2.405, but in case of a multi-mode fiber, V number is greater than 2.405, and the core diameter is very higher, dispersion is higher, lower bandwidth. That is, in case of a single mode fiber, bandwidth is 1000 megahertz, but in case of multi-mode fiber, bandwidth is only 50 megahertz. Used for short distance communication, and a single mode fiber is used for long haul communication. The fabrication is less difficult and not costly, but the single mode fiber is fabrication is difficult and is more costly. That is all about the optical fiber method used for the, that is all about the types of fibers.